All right, let's talk about tangent to the circle. So in this one, it says AB is tangent to the circle. When something is tangent to the circle, it means it only touches the circle once, and it intersects with the radius at a 90-degree angle. So just saying that AB is tangent to the circle automatically means that this angle is 90 degrees. Now, if that's a 90, then I can solve x, because this I can use a Pythagorean theorem. Now, 5 is the radius, which means this is also 5. All right, so it's going to be 5 squared plus 6 squared equals x plus 5 squared, right? So now we're going to add these up. So it's going to be 25 plus 36. That's going to be 56, 61. So 61 equals the third side squared, right? So if we square root this side and square root that one, the answer is going to be x plus 5, square root both sides. Then I'm going to subtract 5 on both sides. So in this odd scenario, where I don't have a calculator, x equals the square root of 61 minus 5. And it's going to stay only positive because we're doing geometry, and there's no such thing as a negative 61 in geometry. The square root of negative 61 in geometry. So the answer would be the square root of 61 minus 5. If you know the answer, please put it in the comments. All right. Now, the next one we're going to be doing here is AB and AC are tangent to the circle. So AB and AC are tangent to the circle. When this happens, this shape right here is going to be a kite, because this is going to be equal to that one. These are both radiuses, so you know they're equal to each other. So what you've created is a kite, meaning any two lines that are tangent to the circle from a specific point are going to be congruent to each other. Now, knowing that, and knowing that this is 160, and knowing that this is tangent to the circle causing a 90, tangent to the circle causing a 90, that's going to be left right here. This angle has to be 20, because in a four-sided shape, it has to add up to 360. If you add up all these angles, you're going to get to 340, and you're going to be missing 20 degrees. All right, so that's another example. Here's another one coming up. So here's another one. So I know that this length here is congruent to this length. So these chords are going to be exactly the same length, because they're the same distance from the center of the circle. And as you get away from the circle, the length starts to become smaller and smaller. So C and D are actually going to be the same length as AB. And AE is going to be half of AB. So AE is congruent to EB. Same thing here. CF is going to be the same as FD, because it's half of CD. And then if I connect them to make a triangle, seeing as though this length is the same as that one, and this is the radius, and that's the radius, that means all three sides of this triangle will be the same as all three sides of this triangle. Like if I did this, if I connected this, connected that, and then connected that, and connected that, because all these sides are radiuses, and these sides are congruent, it automatically means that the entire triangle is congruent through side, side, side. Now, here, let's solve for x and y. This is an inscribed angle, which means y is double, so that's going to make y equal 100. I know that this is another inscribed angle, but it's a tangent inscribed angle, so it looks really odd, but the angle's being made up of only touching the outer wall of the circle. So if this is 60, that means that this part right here is 120. And if that's 120 and that's 100, I have 220. And I know a circle is 360. So if I subtract, I'll end up with 140, which is what this one is, 140. And I'm done. That's it.